I started my career in optics many years ago as an undergraduate student in electrical engineering back in New York City. And I can recall the night in particular. It was a Friday night, it was storming out, and I was looking in the course catalog, and I was thinking about what elective courses would I'd like to take as an electrical engineering student. And I saw one of the courses which said, Introduction to Lasers and Masers. So I read the description, and one of the final things it said is that this course will teach the fundamental underpinnings and concepts of fiber optic communications. And this was about in 1979. And I said to myself then, if I were to get a PhD in that area, because this is the field of the future, it's going to carry me through a career. After I got my PhD, I went to work at Bell Communications Research, and there I started working with semiconductor lasers. These are the small devices that are inside your compact disc player or inside your laser pointer. And I showed how we could turn these laser devices on and off faster than 1/5 of a trillionth of a second. And not only that, did this become the world's shortest pulses from semiconductor lasers. These pulses had the brightest power, so they were both simultaneously the world's shortest and most powerful pulses ever generated from a semiconductor laser. We showed how we could use these lasers for optical clocks as well. And then coming to UCF, we've had many different discoveries and inventions. One which I'm particularly proud of is our way of amplifying short pulses of light from semiconductor lasers. And with that technology, we were able to spin off a company called Radiance. And this is one of the things that I'm being recognized with for receiving this honor at the Florida Inventors Hall of Fame. We were using these lasers to cut the Gorilla Glass in your Samsung phone, to drilling holes inside high precision fuel injectors, and for cutting stents that go inside the human arteries. And the reason why this laser was so unique at the time is that it was using a process of what we call non-thermal ablation. This process of non-thermal ablation, the laser shines on the material, and what it does, it breaks the electronic bond that holds the atoms together. So it removes an electron, and the residual atoms which are left together, they're positive charges, and they basically repel each other and explode out of the material without the production of any heat. And so by doing this, we're able to precisely cut material without any of the edges being scarred or burnt or melted due to the normal way lasers cut material. So you might call this a cold laser. But with that application, we then were able to impact electronics markets for Samsung, the automotive markets with Delfyett Automotives, and the medical market with Boston Scientific. Certainly, I would like to say that I'm truly honored to receive this recognition. Being in the Florida Inventors Hall of Fame is truly one of the highest recognitions I've been able to achieve. There are many other outstanding scientists there, and I have to really give credit to the colleagues I've worked with, the students I've had in my group, the administration here at UCF that supports our activity, the local administration here in Creole. All of these things have helped make this a reality. And as far as where else do we think we can go? Again, we're just sort of limited by our own imagination. And if we kind of take off the blinders and think creatively, there is nothing I think that we cannot do.